Don came to my office and said, "There's a bum in the lobby. And in marketing, you're in charge of cleaning up the lobby. Would you get the bum out of the lobby?" So I went out to the lobby, and this guy's sitting there with holes in both knees. He really needed a shower in a bad way, but he had the most dark, intense eyes, and he said, "I've got this thing we can build." End quote. That transpired at the offices of Shugart Associates sometime in the late 1970s. At the time, Shugart was one of the largest manufacturers of floppy disk drives in the world, and probably the most influential in that market. What's more, they were just on the cusp of releasing the first 5¼ inch floppy drive, a major change to the somewhat stale technology, and it would end up setting the tone for the personal computing revolution. And it was during this transitionary period that a rough-looking, unwashed man dressed in tattered clothes strolled in. His name was Steve Jobs, and he was on the trail of the next big thing in personal computing. Now, at the time, there were a lot of next big things. Useful integrated circuits were first developed in the early 70s. The first microprocessors started to appear around the same time. Viable home computers followed shortly after. Jobs wanted to build a personal computer, something that many other manufacturers were trying to design. No one had yet figured out how exactly to make a computer that would totally fit this personal ideal. But the consensus was that it had to be small, at least small enough to fit on a desktop, and it had to be relatively cheap. Part of getting to that point was getting a small, cheap, and reliable storage medium. And at the end of the 1970s, Shugart would provide just that with the 5¼ inch mini floppy. Now, ultimately, Steve would have to wait in line just like everyone else to get his hands on Shugart's new hot drive. At this point, Jobs wasn't rich, he wasn't all that well known, and he wasn't influential. He was just another eccentric trying to build a computer. But over the coming years, things would change considerably. The Apple II was announced in 1977, and it became a massive success for Jobs and his business partner Steve Wozniak. The next year, 78, a floppy expansion built around Shugart's mini drive would start to ship. But as far as Shugart was concerned, Apple was just a customer, and Jobs would have to settle for following the current trends. Fast forward to 1984, and things had changed. Apple had grown. Jobs was more than just an eccentric nobody, and a new computer was about to be announced. The Apple Macintosh would mark a huge change for computing. Even if the credit isn't solely deserved to Apple, Apple was able to shift its position to firmly setting trends. And one of the often overlooked trends that the Mac popularized can be seen clearly even when the computer isn't turned on. You see, the new computer came stock with a new 3½ inch micro floppy drive. Welcome back to Advent of Computing. I'm your host, Sean Hass, and this is episode 25, Making Disks Flexible, Part 2. Today, we're diving back into the history of the floppy disk. If you haven't already, I'd recommend listening to Part 1. In that episode, I covered the original development of the 8-inch disk at IBM, its migration to early personal computers, the creation of the 5¼ inch disk, and a lot of the context around its rise to popularity. Today, we're picking back up with the tail end of the 5¼ inch disk era and then moving onward. I think this is really where the rubber meets the road. Now, there are a lot of reasons for this, but the setting and time is the biggest factor for me. We're going to be starting off in the early 1980s, that's firmly into the personal computing revolution. Computers were more popular than ever before, and the market was saturated with myriad options for consumers. I think it's fair to say that the IBM PC really set the template for creating a personal computer, both for consumers and manufacturers. All systems that followed would have to fit into that framework somehow, either being billed as a clone or an improvement on that template. Technology of the time would put major limits on what was possible, but advancement was fast. Within the first few years after IBM cracked the PC code, the face of computing would once again change forever. And a big part of that would turn out to be the floppy disk. So why did the 5¼ inch disk, a mainstay for the better part of a decade, need to be replaced? Why was the 3½ inch disk so different both qualitatively and in the details from its predecessor? and how did Apple play a major role in this change? More and more, I've started to become convinced that any story about the history of technology starts off with someone thinking, this current thing sucks, and I'm sick of it. And it seems that with the 5.25-inch floppy disk, there wasn't a single person or event that led to this revelation. Rather, there were known flaws since day one that would only get more frustrating over time. This shouldn't be that surprising. When you get down to it, the mini floppy was just a scaled down 8-inch floppy disk. Besides the change in size, the 5.25-inch disk is almost identical to its larger predecessor. So it came with all the baggage and issues of the older technology. Most of these issues came down to the basic construction of the disk. Floppy disks, or at least the 5.25 and 8-inch variety, were pretty delicate. In order to function, the Mylar disk had to be kept clean, dust-free and smudge-free, had to be kept flat, dry, and fully intact. In theory, the plastic jacket and internal fabric disk kept the Mylar safe. But it only offered limited protections. Part of this problem was that, part of the fragile Mylar disk was left exposed. There had to be a window in the outer casing to allow the drive's read-write head to get to the disk. There wasn't a way to get around that. Every time you used a floppy disk, you had to be careful not to touch this little exposed window of disk, lest your data be lost forever. Disks at the time were often stored in paper sleeves, so while not in use, the floppy was theoretically safe. But the trip from the sleeve to the disk drive and back left a small window of Mylar totally exposed. Another big point of failure was the overall construction of the disk. As the name would suggest, older floppy disks aren't very rigid. That means that, unlike hard drive platters, you can't shatter or crack a floppy disk. This was a logical choice back in the early development of the disk. One of IBM's requirements was that the disk should be easy to ship. And a flexible plastic disk is lightweight and it can hold up in the mail with relatively little risk of damage. But what made early disks so malleable didn't especially help when it came to frequent use. You can do a lot with a floppy that you can't do with a hard disk. And one of those many exclusive features is the fact that you can crumple a floppy disk into a small ball using your bare hands. If you ever handled one, then you know that that's not much of an exaggeration. The inner Mylar disk may be fragile, but so is the flexible plastic housing. The failing of the disk itself may not have been that big of an issue on its own. I mean, you can just treat each disk with a little care and everything should be fine, right? But in concert with the floppy disk drives of the time, a real recipe for disaster starts to unfold. It turns out that under the right circumstances, much like with paper and a printer, you can actually get a floppy disk jam. For a disk to be inserted all the way and then read properly, it had to be aligned on a set of tracks. Simple enough. The actual locking mechanism on floppy drives did vary, but one popular option was to have a full spring-loaded door over the slot that the disk fit into. Now, usually everything went fine. A user would simply flick the door open, push the disk in on its tracks, and then flick the door shut, locking the disk inside ready to use. But if you were working fast or the disk was misaligned or damaged, it was possible to slam the door shut on a not yet fully inserted disk, thus crumpling, bending, or otherwise destroying your data. Sounds pretty bad, right? Well, we're just getting started. There's more issues to go over. The other huge area for errors came down to how the floppy disk is actually held when it's spun. If you look really closely at a 5.25-inch disk, then you realize that the center hole can get a little off-center. That's because the disk's jacket is actually slightly larger than the disk inside. This very small design choice, we're talking about millimeters here, causes some pretty big issues. When a disk is first inserted into the drive, a hub comes down through the center hole that's meant to center the disk. Then a clamp holds the Mylar disk in place and starts it spinning. Or at least that's the idea. In practice, the method, no matter what the specifics, doesn't always work out. Centering is usually the problem, and if the disk is a little off-center, then you can't read or write to it, since the heads need to be pretty accurately aligned over the sectors of the Mylar. So those were the big problems that faced the 5.25-inch disk. Really, those were all the same problems that the 8-inch disk had, just more people were exposed to the newer mini floppy. There were two major schools of thought on the matter. The eventual predominant view was that the 5¼ inch disc would need to be replaced by a very different media, but it would take a while for that view to be in the majority. The fact was that these issues were caused by core design flaws with the disc, but not everyone saw it that way. Instead of ditching the disc for a new design, some companies tried to find a way to extend the old 5¼ inch disc beyond its lifespan. But by far, the larger faction wanted to reinvent the floppy, so to speak. Even with a large part of the computer industry on the same page about the issues of old drives, there were still pretty divergent views on possible solutions. This is where we start getting into some strange and pretty interesting territory. Like I said, there were a lot of early attempts to make a better floppy disk. They were all very different, but each shared a few key design features. Despite differences, the bottom line was each competitor was trying to solve the same problem. So to look at some of the strange disks that could have been, I think it's best to introduce an example. There's a lot to choose from. Makers such as Dyson, Hitachi, Maxell, Canon, and many more all offered their own take on an improved floppy disk. Even IBM would throw their hat into the ring. Now, they all shared a lot of similar features since, after all, they were trying to solve the same set of problems. One of the most popular of these runner-up formats in this category, and the one with the most features, is the CF2, otherwise known as the compact floppy disk. This disk and accompanying drive was designed and produced by a small group of companies that included Matsushita and Hitachi. First appearing in early 1980, the disks were advertised as, quote, compact, easy to carry and mail, dust-proof, and non-bendable. The 3-inch floppy has the powerful advantages that mean success. Sounds like a pretty viable replacement. So, how did the CF2 implement these features? The easiest change to see is the size. The compact floppy disk is, well, pretty compact. At just 3 inches wide, it's a good deal smaller than earlier disks. Besides the size, a different material is used for the disk's casing. The CF2 replaced the standard flexible plastic sleeve with a hard plastic shell. You can't easily bend or crumple one of these compact disks. Alignment issues were solved by integrating an actual hub to the inner disk. Instead of a drive needing to center and then clamp directly onto the delicate mylar of the floppy, a CF2 drive could just connect to a less fragile and pre-centered hub. The other major changes were the shutter and the dust seal. These changes served to protect the inner disk from contamination or scratches by physically sealing the disk from the outside world. The dust seal was basically just a set of rubber gaskets around the outside perimeter of the disk and the read-write window. This kept dust or other grit from getting into the delicate parts of the floppy. The spring-loaded shutter was simply a way to protect the disk from accidental handling. It's a small piece of metal that covers the floppy's read-write head window when it's not in use. The idea is simple, but the CF2's execution is pretty complicated. The disk's shutter is internal, meaning that it slides between the mylar disk and the outer plastic shell. To get to the disk inside, a CF2 drive first has to move that shutter, and on eject, the shutter is closed by a spring inside the floppy disk. In normal operation, the mylar disk is never exposed to the open air, so it's that much harder to damage. Now, if this is all sounding pretty complicated, then we're on the same page. Devices like the CF2 did solve a lot of the problems that contemporary floppy drives faced. But in doing so, these new disks became increasingly complicated. Some of that's to be expected. The reason that the 5¼ inch disk had all these problems to begin with came down to how dirt simple the design was. At the same time, that simplicity was one of the mini floppy's greatest strengths. A simple disk is a lot cheaper, and adding all these improvements drastically increased costs. I've seen reports that a single CF2 disk could cost as much as 5 times as much as a 5¼ inch disk, depending on the manufacturer. And that was a deal breaker at the time. The CF2 disk would see use, but it didn't become the new standard in data storage. Ultimately, many of these early attempts succeeded at miniaturizing and fixing issues with the floppy disk, but they didn't retain the two best features: cheap disks and widespread availability. And it turned out that it would take a little luck and a little good timing for one of these early disks to finally take off. Our story next takes us to an unexpected place: Sony. At the dawn of the 1980s, Sony was known for, among other things, the Walkman, Betamax, and Trinitron TVs. The company was already a global superpower. Just the products I mentioned would have been enough to ensure that. And that was just scratching the surface. If you had a personal computer at the end of the 70s, then you may have loaded data from Sony tapes using a Sony tape recorder and then viewed everything on a Sony TV. But despite being a major player in the world of electronics and producing computer-adjacent products, Sony wasn't involved with computing directly. The new trend was personal computing, and Sony didn't have a personal computer for that trend. Sure, they wanted to join in, but they'd have to start from scratch and try to catch up to established manufacturers. The path that Sony chose to take into computing may seem strange, but at the same time, it may sound kind of familiar. Last episode, we discussed Wang Labs and their word processors. Wang's drive towards a miniaturized system that could fit on a desk led them to partner with Shugart and eventually led to the creation of the 5.25-inch floppy drive. Well, sometime around 1980, Sony started down a similar trajectory. They decided to create a word processor, but in a way that played to their own strengths. The real surprise is that Sony was very well positioned for this shift. Sony already had a lot of experience with magnetic storage via cassette tapes and Betamax. They were also one of the most experienced CRT manufacturers of the time. Their Trinitron tubes were in high demand because they were so well built. And since as far back as the 1950s, Sony had a semiconductor division. Honestly, I find it shocking that Sony wasn't in the computer market a lot earlier. They had everything needed to make a computer totally in-house. Anyway, the first step into the home market was a new word processor, but that was selling the machine a little short. Word about the upcoming Sony's Series 35 was circulating among the community as early as 1980, but the computer wouldn't launch until 82. By the time it hit desks, it was, for all purposes, a fully fledged desktop computer. There aren't Sony internal documents available, or at least none that I was able to find, so we can't be 100% sure on the thought process behind the creation of this machine. So we don't know why certain decisions were made, but we can look at the completed product and make some guesses. The Series 35 came with everything we'd expect in an early home micro. Built around a Zilog Z80 accompanied by 16 kilobytes of RAM and a separate monochrome display, this was a pretty stereotypical 8-bit microcomputer. It came with a package of word processing software from Sony and could connect up to a printer and other assorted peripherals. That's all well and good, but we're here for the storage. So what did the Series 35 use to keep its files safe? To quote from some contemporary articles, quote, "The Series 35 word processor is fitted with two 3.25-inch Sony microfloppy drives, each with a format capacity of 280 kilobytes, end quote. That's right, an obscure computer created by Sony and then marketed as only a word processor is where we find the first 3.5-inch discs. Doesn't seem right, does it? Maybe it's some kind of pattern. The first 5.25-inch discs were also made for a word processor. But in Sony's case, the new disc was designed, developed, and produced in-house. I think, though, that this only seems out of nowhere if you don't look at the context. So let's look at a little bit more information surrounding the Series 35. We can think of Sony's background as at least qualitatively similar to that of IBM when the first 8-inch discs were produced. One of the reasons IBM was able to create the 8-inch floppy disk in the first place was because their engineers were already well versed in how to store data on magnetic media, and they were also knowledgeable about the mechanisms needed for disk-based storage systems. Both companies, Sony and IBM, had a lot of experience with magnetic tape storage. IBM, of course, had the open reel tape drives used by mainframes, and Sony had tape cassettes used for audio and also for early home computers, as well as Betamax. Both were also actively involved with disk-based storage. IBM had their hard drives, and at least as early as the 1970s, Sony was involved with the development of Laserdisc and then eventually the compact disc. Combine that with the buzz around the improved floppy disk formats and an image, as speculative as it may be, really starts to form. Of all the manufacturers that could create an improved floppy disk, Sony was pretty well positioned. So what did this new disk look like, and why did it take off where others failed? Well, there's a good chance that you already know the answer to the first part of this question. The microfloppy was 3.5 inches across. It had a hard plastic shell and an inner mylar disc. A stamped metal hub was bonded to the inner disc so a drive could couple to it and set the disc spinning. Most prominently was the shutter, a folded and spring-loaded metal clip on the top edge of the shell that kept the disc safe while not in use. Compared to its competition, it was a relatively simple design. No need for gaskets or seals, a dead simple shutter that could just be pushed aside as the disc entered the drive, and overall, each part of the disc was relatively simple in its design. Sure, it wasn't as simple as the plastic sandwich that was the 5.25 inch disc, but was probably as close as you could get. As far as costs, I've been able to find the initial price around $5 a disc. That's still a lot more than a 5.25 inch disc, but it's within the realm of real possibility. That's where things stood in 1982. Sony had a new computer with a new storage medium to match, but this is where Sony diverged from the pattern set out by IBM. Instead of keeping the disk drive as part of their computer lineup, Sony committed early on to selling disks and drives to other manufacturers. That small difference in ideology would really make dividends. The same year the Series 35 was released, Sony's microfloppy would get its first big chance, and luckily, Sony had already gained some important supporters. I know last episode I harped on how important standards are, but I'm going to have to come back to that. As someone who works in the computer industry myself, I'm reminded about this every single day. Having an agreed upon standard helps everyone in the industry. And conversely, having no standard is a big problem. We've already seen how the early ad hoc standardization around Sugart's 5.25 inch drive led to the disk's success. It was really important for the burgeoning home computer industry to have a standard and cheap storage device to rally around. But in 1982, the exact opposite case was unfolding. The market for some so-called microfloppy was fractious, with a handful of competitors all offering totally different devices and disks, and they were all totally incompatible. There wasn't just a lack of unified standard, there was a lack of any unity. To try to clear out that field, the Microfloppy Industry Committee was formed. Information on the committee's actual goings-on are somewhat sparse, but we can piece together a pretty good story from contemporary articles in some computer magazines and later interviews. We know that the MIC was made up of delegates from as many as 20 different manufacturers, but the main constituents were all either active or ex-Shugart employees. Their goal was relatively simple: examine existing contenders and create a new standard disk format. But despite the outward goal, many members of the committee already had a choice in mind. Prior to even meeting, flyers proclaiming 3.5 inch as the winner were already being printed. This preemptive choice came down to a few things, but mainly it seems like the Sony disks and their drives were just better engineered than competitors. Dalziel, part of the MIC's Shugart contingent and one of the engineers behind the 5.25 inch disk, was particularly impressed by a few key features. When asked about the shutter and the hub design, Dalziel's quote is saying, quote, "So that just solved all these problems, and then the shutter was so much better than the open design. I mentioned that we put the wiper in here to wipe off stuff, but it's so much. You can still put your finger on it and people don't put them back in the container. So this just, in so many ways, was so good." End quote. The bottom line was that Sony's disk design was simple, well thought out, and solved some of the biggest problems facing floppy disks without being over-engineered. So with a few minor changes, the 3.5 inch floppy disk became an official industry standard. No matter how you cut it, that was a huge boost, making Sony's microfloppy the heir apparent. But being a standard could only go so far for the new format. The next big leap would be towards adoption and actual use in computers outside of Sony. And once again, timing would play a key factor. At the beginning of the episode, I mentioned that there were competing schools of thought about the future of the 5.25 inch floppy disk. There were some that chose to cling to the old ways and others that struck out and eventually created a viable replacement. Now, it may surprise you, but one of the slow-to-change companies was Apple. Eventually, Apple would join the majority in looking for a radically new format, But in the interim, they would make a strange string of mistakes, and Steve Jobs would be at the center of all of it. Apple's own internal disk project, officially known as Fileware but colloquially called Twiggy, started around the same time as Sony's own project. But where Sony's microfloppy was a large revamp of existing technology, Fileware was just an extension. In the words of Andy Hertzfeld, an engineer involved with the project, quote, "Twiggy was a fairly ambitious project, more than quadrupling the capacity of standard floppy disks by doubling the data rate, which required higher density media, and employing other innovative tricks like motor speed control, which slowed down the disk rotation speed on the outer tracks to cram in more data." End quote. Despite being ambitious, Apple wasn't willing to make the same leap that Sony was. Fileware disks would end up being totally incompatible with existing floppy disks, but they retained the same core form factor and functionality. The disks themselves were still 5¼ inches wide and housed in a flexible plastic sleeve, but there were some key differences. The easiest to see was a second window cut out of the plastic sleeve directly opposite the normal cutout. The strange layout was to accommodate a drive with 2 opposing heads. Besides cramming more heads into the drive, there was also the variable speed drive motor. This made it possible to have a different number of sectors in each track. It's a cool trick, sure, but it came at a cost. The control hardware for a Fileware drive was complicated to say the least. So much so that a drive needed to have its own dedicated microprocessor just to function. Apple ended up having their own floppy drive, all built in-house, but that came at a big cost. It was complicated and highly error-prone. That would have been a big issue on its own. Add to that the fact that when you get down to it, a Fileware disk is just a 5¼ inch floppy disk with another set of holes cut into it. So Apple got all the baggage and problems of the older format. Fileware was in development for quite a few number of years, and its launch kept being pushed back while engineers tried to get it to work more reliably. It wouldn't see the light of day until 1983 with the release of the Apple Lisa. Now, there's a lot to be said of Lisa. It was Apple's first attempt at a fully graphical computer, and it predates the Macintosh, but it isn't a direct predecessor. The two computers have a somewhat complicated relationship, to say the least. As a first attempt, Lisa had its problems, and one of the big ones was called Fileware. Mirroring the earlier IBM PC, Apple's new machine came equipped with twin Fileware drives. In testing, the use of these drives had nearly grounded the project. The problem was that Fileware had a pretty high error rate. That may have been acceptable on an older computer, but Lisa was a new kind of machine. There were a lot of resources that go into running a graphical interface. It takes a good deal of code to begin with, but on top of that, you have all the graphical resources needed. Each element you display, from a menu to a window to a scroll bar, has to be stored somewhere, and for Lisa, the lion's share of that data was stored on Fileware disks. This new computer needed to reliably and, at least in theory, quickly access files from its disk, and Fileware was just simply not up to the task. This was abated partly by the inclusion of a hard disk, but Fileware would haunt the early years of the Apple Lisa. The other problem with Apple's new floppy drive came down to the actual monetary cost. As I mentioned, the control hardware for these drives was so complicated that it needed its own microprocessor. That ballooned manufacturing costs on its own. But it gets worse. As it happens, Fileware drives were complicated enough that they were plain hard to manufacture. Around 50% of all Fileware drives failed to pass factory tests and had to be scrapped. So you have an already expensive and delicate piece of machinery made just that much more expensive. It really added to the launch price of Lisa, and using a hard drive to get around the unreliable floppy drives just added even more to the final cost of the machine. To put it bluntly, Apple had bet on the wrong horse, and they were hurting for it. Somehow, they had managed to create a new floppy disk with none of the better aspects of the earlier disk, and all the more problems. Oh, but it gets worse. This is just the beginning. I said this was a string of mistakes, and this is just the first link. As it turns out, the Apple Macintosh, which was still in development as the Lisa was just hitting market, was originally planned to use a single Fileware disk drive. There are actually some pretty cool photos of Jobs and the rest of the Mac crew with this strange prototype computer, complete with the 5¼ inch disk slot. But Lisa failing in the market was really the death knell for fileware. It was decided pretty quickly that Macintosh simply could not ship with the delicate drive. And, as fate would have it, this was exactly smack dab in the middle of 1983. Just a few months prior, the Sony 3.5-inch floppy drive had been codified as an industry standard. Sure, it was still relatively new and unproven technology, but every feature of the new drive lined up with the Mac's requirements. Even better, Sony was slated to start shipping bare drives to manufacturers by the end of the year. It seemed like the Sony drive would be the obvious choice. It's quick, easy, reliable, and cheap. Right? Quoting Hertzfeld again, Steve Jobs was finally ready to acknowledge reality and give up on the Twiggy drive. When he saw the Sony drive, he loved it and immediately wanted to adapt it for the Mac. But instead of doing the obvious thing and striking a deal with Sony, Steve decided that Apple should take what we learned from Twiggy and engineer our own version of a 3.5-inch drive. End quote. Yeah, it can't be that easy. That would just be too good. This may seem like a bad choice on Jobs' part. And, well, it kind of was. So why would Jobs or anyone at Apple want to make another in-house floppy drive? For that matter, why did Apple try their hand with fileware in the first place? Well, it all comes down to vertical integration. In the words of Steve Jobs himself, quote, "I've always wanted to own and control the primary technology in everything we do," end quote. Retaining full control over hardware and software was a major ideology at Apple. It still is today. Keeping this level of control over every detail of a computer is what has made Apple able to be, well, Apple. In the modern day, we can see the strategy in the custom processor used by an iPhone, or even something as simple as the proprietary charging cord used by a MacBook. Making vertical integration such a big part of Apple's business plan has allowed them to keep tight control over every aspect of a user's experience. It shields the company from a lot of third-party competition, and if done correctly, it can help Apple's bottom line. Fileware was an attempt to apply this policy of vertical integration to disk storage. When applied properly, this could have given Apple a huge lead in the personal computing market. But, as we've seen, things didn't go to spec. Despite the first attempt failing, Jobs wasn't ready to give up on his key strategy. So when it became apparent that fileware was a no-go for Macintosh in Jobs' mind, that just meant another opportunity to create their own rendition of the new microfloppy. Really, it just conformed to the overall goals of Apple as a company. But when he pitched that option to the long-suffering engineers that just cleaned their hands of fileware, well, you can imagine how well that must have gone. And this is where things go off the rails in a somewhat wonderful way. All this was going on in the summer of '83, and the Macintosh was set to ship in the winter of 1984. According to Steve's plan, the Macintosh team would be able to create an in-house clone of the 3.5-inch disk drive in a matter of months. If that wasn't a tall enough order, the new drive needed to be reliable and cheap enough to prevent another fileware fiasco. To do all that on schedule would have been a Herculean feat of engineering, if not plain impossible. All of this pressure fell right onto the shoulders of Bob Belleville, the head engineer of the Mac project. Belleville was already well versed in how to navigate the computer industry. He had worked at Xerox for years before being snagged away by Jobs himself. When the mandate of another in-house floppy drive came down, he knew it was an impossible feat. But he also knew that Jobs wouldn't take no for an answer. So Belleville decided to get tricky. On the outside, it looked like the Macintosh team was moving right along with the new floppy drive project. But while keeping up that front, part of the Mac team was secretly meeting with engineers from Sony. As you can imagine, this sort of arrangement could only last for so long. But to his credit, Belleville was able to keep up appearances pretty well. A few Apple engineers were sent to Japan to meet with manufacturers to get estimates on producing a totally new type of disk drive. And they would periodically slip away to meet with Sony. And when Sony engineers made the trip to Apple's offices in California, they would have to periodically slink out the back door or hide in closets to avoid Steve Jobs. It all ended up coming together perfectly. When Belleville finally got quotes back from Apple's manufacturers in Japan, it became clear that Jobs' fool's errand was just that. Designing, testing, and manufacturing a new disk drive and accompanying disks would push the release of the Macintosh back a considerable amount. Faced with that reality, Jobs agreed that another solution would need to be found. And luckily, Belleville had an option in mind. With a few tweaks that were already in the works, the Sony 3.5-inch drive ended up being a perfect fit for the Mac. And in 1984, the computer shipped with the new state-of-the-art drive front and center. So, why does it matter that the Macintosh shipped with a microfloppy drive? Well, it wasn't the first computer to use a 3.5-inch floppy drive. It wasn't even the first computer to use a new, smaller floppy disk in general. What it did do, however, was popularize the format. Getting in with Apple was probably the best publicity Sony could get for their new disk. When we look at the Macintosh computer in context, we see that each part that went into it wasn't radically new. Apple didn't invent the graphical user interface. They didn't invent the mouse. And we can be certain that they didn't invent the microfloppy. But Apple brought all of that and more together into a tidy and very marketable package. As the Mac rose to prominence, it set the trend for computers to come. That trend is often characterized as just a graphical computer, but in reality, it was a whole package. The 3.5-inch disc was a big part of that coming storm. In the following years, the microfloppy would quickly go from an industry standard to the norm in home computers, and a big part of the rapid adoption was thanks to Apple. Alright, so that finally does it for our look into the winding journey of the floppy disk. By the end of the 70s, the 5.25-inch disk was starting to show some major flaws. It's possible that the technology could have stopped then and there. There were enough fundamental problems with the disk's design that it would take a major refactor to get back on track. And in the 80s and 90s, thanks to a combination of Sony's engineering and Apple's brand recognition, the 3.5-inch microfloppy became ascendant. And it really wouldn't take long to catch on. In 1985, just a year after the Macintosh launched, both Commodore and Atari released their own computers sporting Sony floppy drives. And in 1986, the technology would come full circle with the release of the IBM PC Convertible, an early laptop that featured two 3.5-inch floppy drives. The floppy disk would not survive into the 21st century, so how should we remember this technology? If you look back at the full history, it's plain to see that the humble plastic disc is a real survivor. It's a surprisingly simple device, but it was also a hugely effective device. From mainframes to home computers and eventually early laptops, the floppy disk was able to fill an important role for the better part of 40 years. 8-inch disks were able to make mainframes much more flexible by filling the gap between hard drives and magnetic tape. The adoption of the 5.25-inch disc made it possible for computers to fit on a desk, a dream that had existed since the creation of the computer. The PC revolution was greatly shaped by the availability of this technology. Finally, the 3.5-inch disc made computers small enough and reliable enough to expand in complexity and use. A machine like the Macintosh wouldn't have worked as well as it did without the microfloppy drive. Thanks for listening to Advent of Computing. I'll be back in 2 weeks' time with another piece from the story of the computer. And hey, if you like the show, there are now a few ways that you can support it. If you know someone else who would like the show, then why not take a minute to share it with them? You can also rate and review the podcast on Apple Podcasts. And if you want to be a super fan, then you can now support the show through Advent of Computing merch or sign up as a patron on Patreon. Patrons get access to early episodes, polls for the direction of the show, and other assorted perks. You can find links to everything on my website, adventofcomputing.com. If you have any comments or suggestions for a future episode, then shoot me a tweet. I'm at adventofcomp on Twitter. And as always, have a great rest of your day.